Our universe is full of mysteries. From the vast expanse of the cosmos to the intricate details of the smallest particles, there is so much we have yet to understand. The night sky, with its countless stars and galaxies, has always fascinated humanity. We gaze up, filled with wonder and curiosity, pondering the secrets that lie beyond our reach. We look up at the stars and wonder about their secrets. Each star, a distant sun, holds the potential for new worlds and new discoveries. The light from these stars has traveled for millions, sometimes billions of years to reach us, carrying with it stories from the distant past. But there is another world hidden within our own, the quantum world. This is a realm that exists at the smallest scales, where particles behave in ways that defy our everyday understanding. It's a world that is invisible to the naked eye, yet it is fundamental to the nature of everything around us. This is the world of atoms and particles where the rules of our everyday experience break down. In this microscopic universe, particles can be in multiple places at once, and they can even communicate instantaneously across vast distances. It's a place where the classical laws of physics give way to the strange and wonderful principles of quantum mechanics. Quantum physics is the study of this strange and wonderful world. It seeks to understand the behavior of particles at the smallest scales and to uncover the fundamental principles that govern their interactions. This field of study has led to some of the most profound discoveries in the history of science. It is a journey into the heart of reality itself. By delving into the quantum world, we are exploring the very fabric of the universe. We are uncovering the building blocks of matter and the forces that hold everything together. It's a journey that challenges our perceptions and expands our understanding of what is possible. Quantum physics is not just a theory, it is a practical science that has real-world applications. From quantum computing to quantum cryptography, the principles of quantum mechanics are being harnessed to develop new technologies that have the potential to revolutionize our world. It is the most successful theory ever devised by humankind. The predictions made by quantum mechanics have been confirmed by countless experiments, and its principles are the foundation of much of modern physics. The work of pioneering physicists like Max Planck, Albert Einstein, and Niels Bohr has paved the way for a deeper understanding of the universe. It underpins much of our modern technology, from smartphones to lasers. The devices we use every day rely on the principles of quantum mechanics to function. Without quantum physics, many of the technological advancements we take for granted would not be possible. But more than that, quantum physics challenges our very understanding of what reality is. It forces us to reconsider our notions of space, time, and causality. It reveals a universe that is far more complex and mysterious than we ever imagined. It tells us that the world is not as it seems. The quantum world is a place of endless possibilities, where the boundaries of reality are constantly being pushed and redefined. As we continue to explore this hidden universe, we are not only expanding our knowledge, but also reshaping our understanding of the very nature of existence. One of the most mind-boggling aspects of quantum physics is wave-particle duality. This concept challenges our classical understanding of the physical world. In classical physics, objects are either particles or waves, but not both. However, in the quantum realm, this distinction blurs. Imagine throwing a ball. It follows a predictable path, like a particle. You can calculate its trajectory, speed, and where it will land. This is how we understand particles in our everyday world. Now imagine a wave in the ocean, spreading out over a large area. Waves have properties like wavelength and frequency, and they can interfere with each other, creating complex patterns. This is how we understand waves in our everyday world. In the quantum world, things can be both particles and waves at the same time. This means that particles like electrons can exhibit wave-like behavior, such as interference and diffraction. Conversely, waves like light can exhibit particle-like behavior, such as being counted in discrete units. Light, for example, sometimes acts like a wave, creating interference patterns. When light passes through a double slit, it creates a pattern of bright and dark fringes on a screen, which is characteristic of wave behavior. But it can also act like a particle, carrying energy in discrete packets called photons. These photons can be counted individually, and they can knock electrons out of atoms in the photoelectric effect, demonstrating their particle nature. This duality is one of the great mysteries of quantum physics. It challenges our understanding and forces us to rethink the nature of reality. Scientists continue to study wave-particle duality to unlock the secrets of the quantum world, hoping to gain deeper insights into the fundamental workings of the universe. Imagine two particles linked together in a special way. When you measure the state of one particle, you instantly know the state of the other, no matter how far apart they are. This is quantum entanglement, and it baffled even Einstein, who called it spooky action at a distance. Entanglement is not just a theoretical curiosity, it has the potential to revolutionize fields like computing and communications. Imagine sending information instantly across vast distances, or creating unbreakable encryption keys. In our everyday world, we can measure things with precision, but in the quantum world, there is a fundamental limit to what we can know. This is Heisenberg's uncertainty principle. It states that we can never know both the position and momentum of a particle with perfect accuracy. This uncertainty is not due to our limited instruments, it is built into the fabric of reality. The quantum world is inherently fuzzy and probabilistic. Section 5. Quantum tunneling through walls of reality. Imagine throwing a ball at a wall. You would expect it to bounce back, right? This is what happens in our everyday experience. The ball hits the wall, and due to the solid nature of both objects, it rebounds. This is a simple demonstration of classical physics. It will bounce back, right? But what if I told you that in the quantum world, things work a bit differently? In the realm of quantum mechanics, particles behave in ways that defy our everyday logic. But in the quantum world, there is a chance that the ball could pass right through the wall. This phenomenon is known as quantum tunneling. It occurs because particles, like electrons, exhibit both particle-like and wave-like properties. This is called quantum tunneling, and it is a consequence of the wave-like nature of matter. When a particle encounters a barrier, there is a probability that it can tunnel through it, even if it doesn't have enough energy to overcome the barrier in the classical sense. Tunneling is not just a theoretical curiosity. It has real-world applications and is essential for many processes in nature. For instance, it plays a crucial role in nuclear fusion, the process that powers the sun and other stars. It is essential for many processes in nature, from nuclear fusion in stars, where particles tunnel through energy barriers to fuse together, releasing vast amounts of energy, to the functioning of our own cells. In biological systems, quantum tunneling is involved in processes like enzyme reactions and photosynthesis. Without it, life as we know it would not be possible. Quantum tunneling, though seemingly strange, is a fundamental aspect of the universe that bridges the gap between the macroscopic and microscopic worlds. Section 6. Quantum superposition, existing in many states. In the quantum world, objects can exist in multiple states at the same time. This is called superposition. Imagine a coin spinning in the air. It is neither heads nor tails until it lands. Similarly, a quantum particle can be in multiple states simultaneously. Superposition is one of the most counterintuitive aspects of quantum physics. It has profound implications for our understanding of reality and the nature of measurement. Section 7. Quantum computers, the future of computing. Imagine a computer that could solve problems that would take classical computers billions of years to crack. That is the promise of quantum computers. These machines harness the power of superposition and entanglement to perform calculations in a fundamentally different way. Quantum computers are still in their early stages of development, but they have the potential to revolutionize fields like medicine, materials science, and artificial intelligence. Section 8. Quantum biology. Life's quantum secrets. Life itself may depend on quantum mechanics. Recent discoveries suggest that processes like photosynthesis, enzyme catalysis, and even bird navigation may involve quantum effects. This is a new and exciting area of research that could revolutionize our understanding of biology. Quantum biology is still in its infancy, but it highlights the interconnectedness of all things and the profound implications of quantum physics for our understanding of the universe and our place within it. Section 9. Conclusion. The everlasting mystery. Quantum physics is a journey into the unknown. It is a realm where our everyday intuitions break down and we are confronted with the fundamental strangeness of the universe. But it is also a journey of wonder and discovery. As we continue to explore the quantum world, we can expect even more mind-boggling discoveries. It is a journey that will continue to challenge our understanding of reality and push the boundaries of human knowledge.